we have to rationalize an expression that has a complex denominator. And it's easier when the denominator is something simple like just I, right? Then you just multiply by I over I and you're good. Or 5I or 2I or whatever. But this is 2 minus I. So what happens if you multiply by I, right? If I just multiplied this by a crazy one, I over I, think about what's going to happen. On the denominator, who cares about the top? On the bottom, you're going to have 2I minus I squared. That becomes 2I plus 1. It's still complex. So that trick is not going to work when this is a binomial, right? In other words, it's complex. It's got a real and an imaginary part. So instead, let's try something like this. Do you remember how to get rid of imaginary terms from binomials? We multiply by a conjugate. So let's try this. It's going to be a crazier one than before. This time we're multiplying this by a crazy one, which is made of the conjugate of the denominator. 2 plus I, right? That's the complex conjugate. And it'll take a moment to sort out, but we should get something with only real numbers on the bottom. So let's try this. There's going to be foiling involved, right? So 4 times 2 is 8. Then we get plus 4I. Then we get minus 7I times 2, so that's minus 14I. And then minus 7I squared. Okay, which we can simplify. We'll do that in a moment. And for this one, we get 2 times 2 is 4. And then plus 2I. And then minus 2I. And then minus I squared. Okay, so now let's talk about simplifying some things here. First of all, the 2I and the minus 2I, those are going to be great. Those just disappear. Let's simplify what we have. 4I on top minus 10I, so that'll be, minus 14I. That'll be 8 minus 10I on top. And then minus 7I squared, because it's a I squared is just negative 1, this turns into plus 7. And then on the bottom, we have 4. 2I minus 2I cancels out. And then minus I squared is just plus 1. So we keep on simplifying this, and we get 15 minus 10I on the top, and then 5 on the bottom, which we could simplify even more if we want to. You don't need to, but this would become 3 minus 2I. See, that rationalized quite nicely. It won't always simplify like in that last step, and this would be a perfectly acceptable answer. Likewise for this other one, I'm not going to go through all the math, but let's just think about what the complex conjugate would be, and you can work through that if you would like. Well, the complex conjugate means the imaginary number changes its sign. So this is going to be positive 2I minus 5 and positive 2I minus 5. Okay, so there's our crazy one. It's pretty crazy. You FOIL this through, you're going to get something that only has real numbers in the denominator, and that is considered rational.